Amazing to see you. And आज बहुत ही सुंदर मौसम है, आप देख सकते हैं। सन तो ढक चुके हैं बट इट्स ओके। एंड और मैंने मॉर्निंग मेडिटेशन तो कर लिया और अभी मैं स्टडी करूँगी विथ मॉर्निंग वाइब्स। ओके, सो थैंक यू फॉर बीइंग विथ मी। Day after tomorrow is my examination, so I'm studying for that. Electron emission, thermionic emission by heating sufficient thermal energy can be imported to the free electrons to enable them to come out of the metal. Second is field emission. By applying a very strong electric field of the order 10 to the power 8 volt per meter to a metal, electrons can be pulled out of the metal as in a spark plug. Photoelectric emission. When light of suitable frequency illuminates a metal surface, electrons are emitted from the metal surface. These photo-generated electrons are called photoelectrons. De Broglie's relation, lambda equal to h by p, where h is Planck's constant. The value of Planck constant is 6.6 into 10 to the power minus 34 joule second. Okay, and p is the linear momentum. Lambda equal to 12.27 upon under root v in angstrom. Equal to potential difference. The Broglie wavelength associated with large mass is very small as compared to smaller particles. Electron emission by heating sufficient thermal energy can be imparted to the free electrons to enable them to come out of the metal. Field emission, photoelectric light of suitable frequency illuminates the metal surface. Electrons are emitted from the metal surface. These photoemitted electrons are called photoelectrons. Photoelectric effect. When light of suitable frequency is incident on a metal surface, electrons are when light of suitable frequency is emitted on a when light of suitable frequency is incident on a metal surface, electrons are emitted from the metal surface. This is known as photoelectric effect. When light of suitable frequency is incident on a metal surface, electrons are emitted from the metal surface. This is known as photoelectric effect. Photoelectric effect. It follows the law of conservation of energy. It's an instantaneous process. Einstein photoelectric equation. Energy of incident photon equal to maximum kinetic energy of a photoelectron plus work function. That is equal to H equal to half mv square plus W naught. W naught is threshold frequency of minimum frequency work function required to emit energy of incident radiation. Studies on photoelectric effect. The emission of photoelectrons take place only when the frequency of the incident radiation is above a certain critical value. Characteristic of that metal. The emission of photoelectrons take place only when the frequency of the incident radiation is above a certain critical value. Characteristic of that metal. Critical value of frequency is known as threshold frequency for the metal of the emitting electrode. Of photoelectrons take place only when the frequency of the incident radiation is above a certain value. Characteristic of that certain value. Characteristic of that metal. The critical value of frequency is known as the threshold frequency for the metal of the emitting electrode. The emission of photoelectrons start as soon as fall on the metal surface. The maximum kinetic energy with which an electron is emitted from a metal surface is independent of the intensity of the light and depends only upon its frequency. The number of photoelectrons emitted, photoelectric current, is independent of the frequency of the incident line and depends only upon its intensity. Photoelectric current is independent of the frequency of the incident line and depends only upon its intensity. Hertz and Lenard's observations. Observations related to photoelectric effect are: the photocurrent is directly proportional to the number of photoelectrons emitted per second. The photocurrent is directly proportional to the number of photoelectrons emitted per second. Photoelectric effect. The photocurrent is directly proportional to the number of photoelectrons emitted per second. For a given frequency of the incident radiation, the stopping potential is independent of its intensity. For a given frequency of the incident radiation, the stopping potential is independent of its intensity. For a given frequency of the incident radiation, the stopping potential is independent of its intensity. The stopping potential is photocurrent, collector plate potential, retarding potential. For a given frequency of the incident radiation, the stopping potential is independent of its intensity. Greater the frequency of incident light, greater is the maximum kinetic energy. Greater the frequency of incident light, greater is the maximum kinetic energy of the photoelectrons. Higher the threshold frequency, higher the incident radiation. Higher the threshold frequency, higher the incident radiation. Photoelectric current अपॉन इंटेंसिटी का ग्राफ ऐसा होगा. Photo current, collector plate retarding potential, saturation current. Photo current, saturation current. Stopping potential, frequency of incident radiation. 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 फोटो इलेक्ट्रिक करंट जो होता है वो बेसिकली इंडिपेंडेंट होता है किससे? फोटो इलेक्ट्रिक करंट अगर बात करें तो ये इंडिपेंडेंट ऑफ द फ्रीक्वेंसी होता है, मतलब ये फ्रीक्वेंसी पे डिपेंड नहीं करेगा. और ये करेगा किस पे डिपेंड? ये इंटेंसिटी पे डिपेंड करेगा. मतलब इंटेंसिटी लाइट का जितना ज़्यादा होगा उतना फोटो करंट भी उतना ही ज़्यादा होगा. ओके. और सेकेंड पॉइंट भी नोटेड ये हो सकता है कि जो काइनेटिक एनर्जी, मैक्सिमम काइनेटिक एनर्जी होता है वो फ्रीक्वेंसी पे डिपेंड करता है और इंटेंसिटी पे डिपेंड नहीं करता है. तो मतलब कि 2 पॉइंट हमें बहुत ही मस्ट है कि याद होना चाहिए. फर्स्ट ये कि काइनेटिक एनर्जी जो होता है, मैक्सिमम काइनेटिक एनर्जी फोटो इलेक्ट्रॉन्स का मीन्स इंसिडेंट लाइट का जो मैक्सिमम काइनेटिक एनर्जी जो होता है जो इमिटेड इलेक्ट्रॉन्स होता है, इमिटेड इलेक्ट्रॉन्स का मैक्सिमम काइनेटिक एनर्जी वो किस पे डिपेंड करेगा? वो डिपेंड करेगा ये फ्रीक्वेंसी ऑफ लाइट पे. मतलब जितना फ्रीक्वेंसी ऑफ लाइट होगा उतना काइनेटिक एनर्जी ज़्यादा होगा फोटो इलेक्ट्रॉन्स का, मतलब इमिटेड फोटो इलेक्ट्रॉन्स का. और मीन्स ये इंटेंसिटी पे डिपेंड नहीं करेगा काइनेटिक एनर्जी. ओके. और बात करें फ़ोटो करंट की तो इसमें ये डिपेंड करेगा इंटेंसिटी पे, फ्रीक्वेंसी पे नहीं डिपेंड करेगा. ओके. An atom is composed of positively charged particles. Majority of the mass of an atom was concentrated at the nucleus of an atom. It was found out later that the very small and dense nucleus of an atom is composed of neutrons and protons. Atom's nucleus is surrounded by the negatively charged particles called electrons. The electrons revolve around the nucleus in a fixed circular path at very high speed. These fixed circular paths were termed as orbits. Nucleus is surrounded by negatively charged particles called electrons. The electrons revolve around the nucleus in a fixed circular path at very high speed. These fixed circular paths were termed as orbits. The size of the nucleus of an atom is very small in comparison to the total size of an atom. An atom has net charge, or they are electrically neutral because electrons are negatively charged and densely concentrated nucleus is positively charged. A strong electrostatic force of attraction hold together the nucleus and the electrons. Limitations. रदरफोर्ड मॉडल के लिमिटेशंस क्या है? Rutherford's model was unable to explain the stability of the atom. Rutherford atomic model was not following Maxwell's theory and it was unable to explain an atom's stability. Rutherford